Hi everyone, and today I'm pleased to be talking about the latest OpenAI model. It's called GPT-o1, or otherwise known as Strawberry by Sam Altman. So today we'll be going to take a look at this model, how it claims to be doing reasoning, and we're going to analyze some possible, architectures of how this could be done. So all this, for architectures part, these are speculation because OpenAI did not release anything on their multiple documents on it. Okay, so let's begin. So the main idea of GPT-o1 is that, instead of getting the model to output only once, like, the traditional LLM, when you give it a prompt, it comes out a response. Why can't we, use that response and do a further chain of thought to like say, hey, what should I do next? And like, is my earlier response correct and so on? So the model can actually look at what it has output earlier and then decide, okay, should I do something else? Should I correct my earlier mistake and so on? So this is called chain of thought. Okay, this chain of thought actually has been used by many different papers. And the chain of thought that they are using here is quite different from the traditional approach. So I'll be elaborating this in the further slides later. The main thing is that the model does not just output once. Okay, it actually analyzes its earlier results and outputs some more, like multiple steps and so on. Okay, and there's another thing that that was quite interesting in the model response is that there could be multiple same outputs for like a certain prompt. Like you ask it to count the letters of R in strawberry, it can do counting letters by inspection, counting letters by an array and so on. So there's two different methods and so on. So this hints that the model is actually doing multiple samples. Okay, so like when given the same prompt, it's able to generate diversified outputs and perhaps consolidate the result later. Okay, so these are the two main features of this GPT-o1. In their benchmark results, actually, this multiple samples is very important. When they scale it up to like 1,000 samples, it became like the top 10 percentile of competitive programming. Okay, but if you don't sample multiple times, it's like maybe 50th percentile and so on. So these two ideas are quite crucial. These are not new ideas, but it's the first time that someone has marketed it as part of the model itself. So let's take a look at the benchmarks. You can see that GPT-o1 is actually pretty good at these three domains, all right? So what are the three domains? Math, code, and science questions. So I believe they spent a lot of time training on all this. Perhaps they hired the PhD students to write the answers and so on and train on those. Okay, so this is something quite impressive because you look at the gains based on GPT-4o, it's like at least a 10% gain for some of them, like this one. And this dark one is GPT-4o and the light one is o1. Hey, sorry, let me see. Oh, okay, sorry. This is not the graph that showed the comparison. That's the next graph. Let me erase again. You can see that the performance of GPT-4o is this one, and o1 preview is this one. So you can see that there's a big jump, like 40% increase. If you look here, 50% increase. This is pretty convincing, if you ask me. And actually, I use o1 myself, and indeed, they are able to solve trickier and more complex problems just simply by the added chain of thought reasoning. So if you look here, this is the one that showed 4o and o1, all right? That's why I was confused earlier. So you can see that the biggest benchmark improvements are like math. These are physics, okay, it's related to math, chemistry, okay, maths, again, yeah, logic, and this logical set, if I remember correctly. So this basically shows that they spent a lot of effort fine-tuning on this kind of data sets, like math, coding, like logic puzzles, maybe, yeah. And you can see that stuff like English, public relations, the gains are minimal, but there's still some transfer learning going on. So it's very likely that they are not tuning on these data sets for GPT-o1, right? The main things that I think they are training on, again, this is speculation, are all those very, very like require multiple steps to reason about the answer, like math, physics, and so on. Chemistry also, biology. Yeah, they show quite a lot of examples of all this on their videos. So there's some gain here. So let's see, how did they do this? Like, how did they give, like if you look at the math gain, it's impressive. That's like 30 to 40 percentage points. That's impressive, like really, because math, this is not easy for an LLM to solve. And if this is done without any computer program, it means LLMs can do math. Okay, but as you already know, based on my earlier sessions, like I have no faith that the LLM can do math. All right. So if GPT-o1 shows this kind of performance without any calculator involved, I actually have my doubts. Okay. I fear that it might have overtrained on these data sets, because like there's no way you can do like this kind of like find the roots kind of thing without actually computing it. Like it is very hard to believe that given the projected equation, you can get the roots without using a computer program, right? So GPT-o1 very likely just uses the text as the action space. Basically, they just use the large language model to output, and then based on the earlier responses, it corrects the earlier outputs and so on. Because I have checked the difference between 4.0 and o1. Like if you ask o1 to generate prime numbers, it just talks about the different steps and gives you the prime number without any calculator or program. But if you ask GPT-4.0 to give you like the 1000 prime, it creates a program, runs the program, and give you the answer. So it is highly likely that o1 does not have a computer program at all. I think Zeri also tried to do multiplication of big numbers, and the approach that it did was to round it off to the nearest hundred or thousands and do subtraction and so on. So it is very likely that there's no calculator involved in GPT-o1, which is quite impressive actually, because it can still do the large number calculation without the calculator. So this is one of the key features of o1, that it doesn't integrate with any external tools, and it's also room for improvement, because if you use external tools, it could be more reliable. Okay, but in this o1, it's purely, at least based on my knowledge, okay, there's no tool used at all. All right, so the baselines for the benchmarks are really quite impressive, but is it really like that great on stuff that is not trained on? So this is the up price. So up, if you look at my previous videos, it's about like an IQ test where you take in, I just draw something like take in a grid of squares. And then like maybe in this grid of squares, you have a red square here. And then the output grid of squares, maybe you want to shift the red square to the right. Okay, so you don't actually have a description of what to do to the program. The program needs to infer from the inputs to the outputs and deduce the rule of what it needs to do. And you can see that just by inspection, o1 preview, it's actually not bad. It's much better than GPT-4.0, right? So if anyone wants to solve the up price, actually o1 preview is quite decent, okay? But actually it's kind of on par with Claude 3.5. The verification score here is a bit higher, but you can see that time taken is like at least 10 times more than Claude. So what this means is that, while the advanced reasoning pipelines might be useful for like math, physics, chemistry, biology, basically pretty much whatever they train it on, and perhaps use PhDs to, give the answers and so on. Yeah, so this is reflective that, this advanced reasoning abilities may not transfer very well outside. Like here, you can see that, yes, there's a gain, but, it's not a very significant gain over like other models. Okay, but that said, I've seen other people do some benchmarks on like IQ tests, and it does much better than Claude 3.5. So I again suspect that maybe the IQ test stuff are in the training set. And also there's other kind of evidence that, o1 preview actually can hallucinate a lot more than GPT-4.0. If you look at the technical report, they also highlight that. This actually shows that, if you want the model to do all this advanced reasoning stuff, sometimes it can think too much. Okay, so I'll touch on that in the discussion. Okay, so this is something very, very interesting, because this is like introducing some form of a bias. Asking it to think more could be some form of bias that will work well for this kind of problems, like even up challenge or so, it might work well because you need to think through about the rules. But for simpler stuff, like give very obvious things like the surgeon is the boy's father, they repeat it twice, then they can come out like, oh, I don't know if you've seen that circulating, like then they'll come out like, oh, the surgeon is the other boy's father. Yeah, so it thinks too much in certain situations. Okay, so Terry, you asked how do you make it do vision tasks? So I believe when they compared all these models here, they did not use vision. They just use it as a like ASCII text array and ask it to generate the text array as well. So at least this is what I understand for their baselines here. Yeah. Okay, I'm going to move on. So now let's take a look at the famous example of the strawberry. So OpenAI actually wanted to name this strawberry. I believe it's because of this. So let's see what's this interesting case of the strawberry about. So this is GPT-4o. Okay, you can try it now. I just tried it yesterday. It's still the same. So you can ask how many R are there in strawberry. And the answer that it gives is there's 2 R's in strawberry. So, people always say that, hey, GPT is like high school intelligence or something like, but you can't even count this. So if you look here, you can see that there's actually 3 R's over here, but the output 2. Okay. And this actually is not really a fault of the LM. It's because like if you take a look at tokenization of this, the strawberry, if you use like byte pair encoding and so on, it might be encoded as straw and bear and re. Yeah, I can't remember what's the exact encoding, but something like this, you will see that if you code something like this, when it comes to the LM itself, the LM does not see letters. Let me just emphasize here again. The LM does not see letters at all. Okay, it does not see them because everything is in sub words in terms of the tokenization. So it sees like stuff like straw, bear, and re. And if you want it to count the number of R's, okay, it doesn't really do that well. Okay, so that's one thing that makes this task difficult for LMs. In fact, if sometimes I ask you the reason by breaking down the words, then you can say that the letters are STRAWBERRY, and then it will give me a response like counting them, I get 2 R's. So there's 2 problems here. One problem is that it cannot really see the letters. The second problem is that it can't really count the letters. If you look here, even if you get a response like this, it's not able to count properly. So if you ask LM to do math and logic, I'm not too sure how well it can do it actually. Yeah. So with the benchmarks that we saw earlier in O1, I'm quite doubtful because it's it might be a case of overtraining. So I can't really comment that much because I don't know the base model. Okay. But just based on what task is asked to do, I have my doubts that this is the right approach. Okay. So you see how you're gonna ask a model that takes in subwords to count letters. Okay, you can't. It's just the wrong domain that you're asking it to evaluate on. Okay, and stuff like counting, this is better done with code. Okay, we shouldn't use LMs for this. Okay, but it's been emphasized that hey, it works. GPT-o1 works. Look at this. This is GPT-o1. How many R's are there in strawberry? So they will think a while. It will show you the thought process. Like, okay, I'm counting the letter occurrences. Okay, I'm counting the occurrences. So then this is the summary. So just take note that this summary here is actually not the actual reasoning tokens. Okay, it's actually the summarized version or the filtered version that takes away all with the safeguards. So OpenAI did not give us the actual steps that the model actually does. They just use a post-processing method to interpret the tokens, and these are the like summarized what we have done. So like first one is like I'm mapping out how to count the number of R's. This involves listing the word and telling R to each total. Right, then he's counting the R positions and finding the 3 R's at these positions, 3, 8, and 9. So 3, 4, 5, 6, 7, 8, and 9. So actually quite good. I mean, to be honest, if it's able to give the positions like this, its understanding of letter positions is much better. So there's another reason why I can think this is happening. Like they might have given GPT-o1 letter-based data sets. Yeah. So it's just to train this, or the tokenization could just be different for some tasks. But either way, GPT-o1 can get the counting task right some of the time. I mean, if we look at some other examples online, if they ask like how many R's are there in like maybe strawberry, sometimes it will get this kind of stuff wrong. All right, so it just hints that that this might be a nature of the training set that has all these examples. All right, and if you just deviate from the training set, a bit quite drastically, this method of using LLMs to count may not be very reliable. Okay, but for Strawberry, it works. And I would say that this is an improvement. At least it works on some letter-based tasks, right? But as you know, my argument for the earlier part, I don't think this is the scalable kind of approach for reasoning because the domain is wrong. Like we shouldn't be using LLMs for this kind of stuff that is not even in their input space. All right, so just to talk about TaskGen a bit, because I've been always wondering, like, whether this Strawberry for GPT-o1, like this task here, it kind of fits quite similarly to the subtask that I have in the agentic framework that I'm building. So it's like you take a task, you map out into subtasks. Okay, but this framework is better in the sense that you can call any function, like you don't have to just use LLMs. You can also pass to an agent and so on. So I'm just thinking like, is there a way to map the stuff into subtasks in an agentic framework and have it perform as well as O1? Okay, so I tried. So I define an agent, like generate this agent, break down the task into smaller steps and critically reason over them. Actually, I realized if I take this out, it still works about the same. So the thing is, GPT-o1 is a different model altogether. They train on very explicit reasoning data sets that 4o is not really trained on. So 4o is not as great as reasoning by default. Okay, so if I wrap it across like this, I ask how many are in the Strawberry. They identify, okay, the first task is to count the occurrences of the letter R in Strawberry. Okay, quite similar to O1, right? Then it breaks down into tasks like this and then counts the letter R as 3. Yeah, at first I was quite impressed with this. Then I tried out different variations of the words and, it kind of breaks down after a while. So O1 doesn't break down as often as, using this agentic wrapper over 4o. I suspect because O1's training data set has a lot more of such examples. All right, so you can see that after the task is done, we can actually ask the agent to just reply, summarize each subtask, display to user in a concise manner in this format, subtask summary. So you can see over here, this looks very, very similar to how O1 shows you the chain of thought. Like you have the step here, and then you have the description over here. So I can replicate most of it with TaskGen, right? Then you can have the final answer here by just replying the user, the answer is 3. So, I suspect this kind of agentic structure is very, very similar to what O1 is doing, at least at inference time. Okay, because they mentioned that they use reinforcement learning and so on. I don't think the reinforcement learning is used at inference time. It's probably used to, augment their data set to make it better. All right. So this leads me to the next point, how can we imbue such thinking into the LLMs, right? So actually, before I move on, I just want to pause here. Like, you all have anything you want to ask about O1 before I move on to like the possible architectures? Or like, at least how's your experience using it? Maybe you want to just share? Okay. Yeah, Derek,
I
go
know,
ahead.
yeah, I know Evan was asking, but um, I brought up earlier at least in the online discussion on the server, because I keep thinking about grokking. Grokking, for some reason, if you're familiar with it, I've read literature a lot about it, just because it's the idea that you kind of get past this issue of like generalization that we're talking about right now, about like reasoning and everything, and trying to get it to get the answer right, but you basically train it to the point of like dullness. You get it to get the answer right through brute force. But grokking has had some interesting literature recently about implicit reasoning, and that if you're able to overtrain the model enough, way past the generalization point, you keep training it, you just keep overtraining it, it does generalize with decent implicit reasoning. And I'm just curious about like if there's possible training techniques being integrated here. I'm not saying they went all the way, but it's possible that they use some techniques from grokking to get the LLM to this point. I still think it's very brittle. I don't like the approach overall because it's a lot of work for a little payoff. Because grokking is extremely expensive, but for someone like OpenAI, they can afford it. So it'd be interesting to see how much grokking they are using in this system. It might not even be that complex. They might even be using grokking. It might be something simpler with like the
Yeah,
reinforcement learning process and
yeah,
the data curation.
yeah, indeed. Later I can talk a bit more about how I think OpenAI did the data curation. It's not in the slides, but if you look at the paper, self-taught reasoner,
Hmm.
is a star paper. this basically tells you about like how, okay, maybe I can talk about it now. Like you have like the question and you have your answer. And then what you do is, you ask the LM to give a rationale. So this rationale, after that you test out, okay, question plus rationale. And then, if you get the answer, then you can augment this to data set. So essentially, it's able to take the question and then the reasoning that is generated. And, this becomes part of the data set. And, it sort of helps the model to implicitly reason because they have seen these examples of reasoning in the data set itself. And, the cool thing is that even if the LM, gets the wrong answer here, if LM gets wrong answer, if or the rationale is wrong, you can actually ask it like question, and then you can give it answer with the correct one, and then ask it to. Yeah. So because of this way of doing it, like there's two ways to get the rationale. One is LM generate automatically. One is, you give the correct answer. And you are able to curate a data set with all this rationale here. And this rationale can get more and more advanced because as your model improves, okay, you can get the improved model to give the rationale. And, okay, I mean, just give you an example for this. Later, you see, like the way the question is like, what is 1 plus 1? Then like the rationale would be like, the way to do this is to count like fingers and add one finger to another. Yeah. And then the answer is like 2. Yeah. So without the rationale is like, what is 1 plus 1? Then there's this is not like very obvious to get to here. So this rationale here is actually otherwise known as a chain of thought reasoning, because like it tells you about like how to think about things and so on. And here the curious thing about this star paper, which has been cited a lot of times, this curious thing about this paper is that it's able to augment the data set with the LM itself. So it's like bootstrapping on its own learning. So this rationale that the LM has come up with, this will be part of the data set that's trained on. And then, based on this, you can get better and better rationales, as you generalize across the whole data set. And yeah, I think there's some merit in this. But I suspect O1 uses something like this because this might be, in the rationale, it might be, okay, I need to tally the R to reach the total list of word. This might occur for all the letter-based tasks. Okay, so there's some merit to this. You can transfer learn to other similar tasks, but if your task is very different, let me just emphasize this here. If task is very different from pre-training tasks, the rationale can impede the progress. Okay, what do I mean by this? If I already learn how to generate this rationale and I give you a task that is completely different from what you have earlier, like here, what is 1 plus 1, right? Suppose, my answer for what is 1 plus 1 is now, my answer is 10, binary, okay? Nothing in my training set says binary, nothing. And, if you do like what is 1 plus 1, maybe the model has some knowledge of binary, but because of this rationale overriding its thought process because it's in the data set, the next token prediction will predict this rationale rather than, going through the binary route. You may not be able to reach this answer. So this is the case for the very famous, I don't have that. I should have put this in the slides, the surgeon is the boy's father, and then, and then there's some chunk of text here. And then like, what is the relationship of the surgeon to the boy? So actually the answer is the father because it's already given this. By the way, just to check, who here has seen this prompt before? This surgeon one. Yeah. No, I did not test this on O1. This is what I read online. But based on what I see, the answer for this is quite hilarious because like what I suspect is that, in the logical data sets for this, the brain teasers kind of thing, the answer is always not straightforward. So it kind of tries to, at least based on what I saw on my LinkedIn post and so on, it tries to guess that this is part of like this not so straightforward. I try to guess like different kinds of responses for this that is not the straightforward one. So the answer that you get is that is like the surgeon is the boy's other father, or the surgeon is the boy's mother, that kind of stuff. This is likely because when you do this kind of training on this rationale, if the task is too different, then you're gonna have difficulties to get the right answer. So this is a form of bias. Okay, and I suspect this is what O1 is doing. They have baked in the rationale as part of the model's data set using some form of, maybe bootstrapping of the rationale, or, getting PhDs to write the rationale. But this is a marked improvement over 4.0, definitely a marked improvement, because 4.0 you can see that, it's not as good. And if you use this kind of, bootstrapping over your reasoning, if they are using the star kind of method, the improvements are quite significant. Okay? But the improvements are, like, this are probably just limited to these domains. If you try to do something very different, I'm not too sure whether it will transfer, right? So you said it's not that different from how human students learn in school. Yeah, I guess so. Yeah, if you can learn from a good tutor, then this would be good. But in the bootstrapping case, your reasoning is generated by the LLM itself. So if the LLM is not good at reasoning or getting the rationale, you won't get a good result.
My speculation, or I think I also saw this somewhere. So they still use human data to bootstrap the self, like when they generate the reasoning trace by themselves, they still use human data to bootstrap, and think of it as AlphaGo. Initially, you still need expert human data.
Yeah, possible. So this might be started with human expert data as the rationale, and then the model will just self-generate the future rationales on its own. Yeah, so I think that is highly likely to be the case. I just did not put it at the slides because I'm actually not very sure like how they did it. They never said anything about it, like, except there is a reinforcement learning method, which
Actually, they do have some hints here and there. You look at the PV on YouTube. One of the researcher did mention oh wait, sorry. That one, okay, they only mentioned like use the syntactic, like the generated one, not really say anything about the bootstrapping. Okay, never mind.
Yeah, no worries. I mean, we have no idea about how it works internally, but at least the idea of this bootstrapping makes sense to me. And based on what I've seen of what has been done online, I suspect this is the case. So
Oh yeah, I know. I remember they say it's something like very much efficient than that how they train it previously. So by sample efficiency, I feel like they are just hinting towards that approach. Yes.
yeah. So anyway, my personal take on the reinforcement learning part actually is not really reinforcement learning. Maybe it's just, getting the correct rationales and bootstrapping on it. Then they call it reinforcement learning. But if you use the traditional reinforcement learning, like the reward model, to gauge how good your answer is by a scalar value, I don't think that's a good approach. Okay, so I'm a bit jumping the gun here. Let's go through the slides. I'll eventually reach the slide on the reinforcement learning part. So first we start with traditional chain of thought. So this traditional chain of thought is like this, if you have a math question, Roger has 5 tennis balls, he buys 2 more cans of tennis balls, and blah, blah, blah. The answer is 11. So you can see, this is, okay, this is correct. Okay. But this is the one shot prompt. And then like now the cafeteria has 23 apples. They use 20 to make lunch and buy 6 more. How many apples they have? 27. So this is wrong, okay? Because if the model learns from this one-shot example, it learns nothing except the answer, because it doesn't know like, oh, how does this tennis ball gets added up? But if in your answer itself you give the rationale, like you give 5 balls, 2 cans of 3 tennis balls, is 6, 5 plus 6 is 11. Then you ask the model to output, then the model might follow a similar style. Oh, had 23 apples initially, they used 20 to make lunch, so it's 23 minus 20 is 3. About 6 more apples, so 3 plus 6 equals to 9. Okay, so they realized that using better answers. So for these answers, they got like high school teachers to go and label the answers, if I'm not wrong. So like, again, this might be done by OpenAI. So I think PhD pay them quite a high rate per hour and getting them to answer these questions with extended reasoning. That I can see that totally happening at OpenAI for a company with billions of dollars. What's a few $100 per hour for each PhD going to cost, right? So so you could have a huge data set of this kind of answers, and these answers could help to increase the ability of the LM to solve tasks, because like the steps are quite well defined, and each of these steps here could help to break down the problem into simple steps. Like here, instead of doing the whole thing at one go, you can say that, okay, I do 23 minus 20 is 3 first, then 3 plus 6 equals to 9. If you look at the other paper, it's called Let's Think, zero shot, LMs can be zero shot reasoners. Most famously written by this quote, let's think step by step. So they said that instead of giving the answer of a detailed reasoning answer like this, you can just simply prompt the LM, let's think step by step. And then like this step by step could already come up with some reasoning that looks like this for math. I mean, like this is basically like this might cue some data set that uses this in the pre-training. So let's think back step by step is one example of this. And the framework that I like the best, like React framework, reasoning and acting framework. So they basically take an observation from the environment. Then they ask the model to output their thoughts and then output the action. So instead of saying let's think step by step, this is a bit more structured approach. You already structure like, okay, I want to, maybe if I see like, okay, can on the floor, then my thoughts is, my goal is to pick up the can. I should pick it up. Then the action could be, pick up can. So this React framework is very useful. In fact, in TaskGen, I use this kind of variant of this quite extensively. And this helps to ground it to the environment itself. Much better than like let's think step by step. And this kind of reasoning, I think, is better than, even what O1 is using. Because like O1 does it for general problems, all right? That, supposedly can go to any domain. But, being too general may not be a good thing. If you are too general, what will likely happen is that you are not able to guide the thoughts in such a manner like this that is a bit more, targeted at what you need. Like in this case, this is environment-based simulation. You might be better off, asking the LLM to come up with their like reasoning for what they should do. Like first you take this from the environment, then you ask the reasoning, and then you take the actions here. So I think something like this is actually a bit more robust than asking the model to, hey, let's think step by step, or give the examples here. Like something like this might be more structured and more robust. Okay, so these are like how chain of thought is traditionally done. Okay, in the interest of time, I'll just skip to the next few slides. I'll pause later for questions. Okay, so what O1 is doing mimics a lot, like how you wrap the LM in an agent and asking the agent to go through, find out the next step. So like TaskGen does this natively. Like so, a task could be like task could be right. Okay, let me think of this. Okay, pick up can. Okay, I don't use a robot task. I use the LM task. Like find me a word that rhymes with pool and write a poem on it. So the first task could be like, okay, one word that rhymes with pool is cool. Then the step 2 could be like, this is the poem with pool. And you can have the poem over here. And then maybe the last step could be like, okay, let me refine the poem, Yep. So something like this, this could be a very natural flow of a few steps to improve on your initial prompt. And each step can take all the information from previous steps because they have to, right? I mean, you need to know that, okay, this word cool is used. So like you have the word cool here. And then, you go to step 2 and then you can get the poem, and then you can take the poem here to do step 3. So, you kind of need all this previous information to do all your stuff. Okay. And in the actual agentic chain of thought, you actually can show your output to user. It's just that gpt-o1 doesn't really show it for safety reasons, they claim. All right. And they show the summary instead. Okay, so just one thing to highlight here. If we take all the previous information from previous steps, this makes sense because, like when you generate next tokens, you can use everything earlier as your context. So actually this agentic chain of thought makes sense in the LM context to generate different subtasks as well in like gpt-o1. Okay. The only drawback for this is this. You might get irrelevant context. Yeah, because like if you use everything before as your context for the next task, sometimes the first step might say, X is 1, then the next step might say X is 2, then you might get confused. So I think what might be better is like, if you already have your fixed task itself, you can already say that, hey, I want to just pass down only this relevant info rather than the whole thing. So yeah, these are the kind of things that, I think there's a trade-off between like general versus specific systems. Okay, this is my claim, all right? My claim is that we will just use specific systems or specific tasks. Okay, general models used for tasks that are not defined at runtime. Yeah. So if you already have a specific task you want to do, like if you want to create this poem word with rhymes with pool and write a poem, you don't need to pass all the context earlier. You can just pass in those things that are needed. Okay, if you already know the process. But if you don't know that this is your task that's going to be done at runtime, then it makes sense to just put everything earlier as your context, because you never know what is needed. So there's a trade-off. So this one is more for like industry needs. Okay, if you want to have very, very, very specific processes that you want to get it right, then you will do this. Like you'll just pass in what's needed for each step to another step. But stuff like GPT-o1 will be useful for the later case where at runtime you don't know what you need to do. Then it's okay to incur more expense for the reasoning and so on, as long as you get the job done. Right. So this is I believe o1 mimics this agentic chain of thought very closely. Okay. Yeah, pause here for a while. Any comments, questions?
One comment on your comment on selecting the relevant context from the previous steps. I think that's not a trivial problem. Yeah.
Yeah, but if you solve it, it will improve the reliability a lot more.
Because yeah, it's not clear. Like it's not necessary. Sorry, it's not necessary. Your step 3 definitely has the most relevant info from step 2, right? Yeah.
Yeah, it depends on what you need from the earlier side. So if you already know in advance what this flow is, you can already depict like, okay, these are the variables I want to get. Yeah. So this is again based on like what you need, but at least for the o1 context, I think it's safe to assume that they just pass in everything earlier, because that's the safest way.
Okay.
Okay, so this is one way to do the like o1 like behavior and agentic chain of thought. What I found is that they actually do the same step multiple times, like about twice in my experiments, and I kind of suspect that like it could be that they already have a meta step here, and then within this meta step they maybe use two different models or two models with different biases to get two different outputs, and then you consolidate the output and then maybe pass it to the next step and so on. So this is one way we can do this multiple sampling and consolidation. The other way, which I think may be a bit more viable for OpenAI case, is that you have one model here, you feed in the task, you get the output. You take another agent here, feed in the task, get the output. And then you can pass in all these reasoning traces. Okay, for all three models or two models. You can pass all these reasoning traces. So this is one way to get the task done. Also, like if you want to have a bit more robustness, you could have two different agents or three different agents doing stuff, and then consolidate a common answer. So earlier on, what you saw in the previous slide was a step-based consolidation. Agent-based consolidation is possible. So in fact, this might be preferred because then each agent can run in parallel. You don't have to wait for all the agents to finish each step. This might be faster. Okay, and it's been shown, like even for the up challenge and so on, like if you just sample the output multiple times, if your model has some idea of the answer, you might get a better result altogether. Like typically multiple sampling doesn't really hurt performance. It normally leads to an increase in performance. So this is something I think is already pre-baked into o1. Okay, o1 might not just be an LLM model, it might be two LLM models. Later I'll show you why I think so. All right, at least in the o1 preview on the web version. All right, so this is the last kind of variant that I can think of for like this multiple step chain of thought. And this is like this. So instead of like just doing different agents, you could have a task here, and then you could just like say, hey, I'm going to sample this one time. So I could get one step here, variant one. I could score it with some reward model to say like how close this is to solving the task. Okay, then next step, I will like, okay, based on this is my highest score, I should do this. Okay, I get a score 0 here. So then maybe if you do something like a Monte Carlo tree search, you might want to say, hey, yeah, I know that this is a score of 1, but I haven't really explored something else here. Then I'll do an exploration step to find another step here. And then, oh, the score is 0.5. Okay, not so good. Okay, so next step, maybe I have to exploit again. Okay, so again, this is based on like the exploit equation based on, if you are interested, it's called the upper confidence bounds. Okay, UCB or upper confidence bounds for trees. People normally use this kind of thing. It's in Monte Carlo tree search. You can go and Google this Monte Carlo tree search. Then maybe the next step I want to exploit. So I get this, and then the score is 1, very good. Then from this, I choose my best branches. Like in this case, top K paths is I just illustrate top 1 path. So I just take the path that is the most promising, which is this path here, and then I get my answer out. So this kind of tree search approach might be better than multiple agents, might be better than repeated process for each step, because it's able to spend most time on the most promising branches. Okay, but what's the drawback for this? Okay, the drawback for this is that because every time you need to pick a node that's most promising to expand it, you need to kind of have a way to evaluate the node. Okay, to see like whether or not you can reach the answer. But based on my understanding of LLMs and my usage of it, LLMs can be quite poor gauges of how close it is to the final answer, because sometimes it might think, oh, it's very near, this is the right approach, but it's confidently wrong. So even you ask for confidence score, the LLM also might get it wrong. This is probably full of errors if you get this accuracy thing, because it might be good for one domain if you train it well. With this score here, you might, ask like some human labelers to label how close it is, then you can do your RLHF or whatever, with the score here. But the problem with this is that, this score is so arbitrary. I mean, if it's LM based, it might be full of errors. If it's a RL from humans, might have errors generalizing to other non-similar domains. So in general, I'm not very optimistic of this kind of RL based scoring based method, especially if the score is just one number, because what's that number going to tell you? Nothing much, right? It's going to just say, oh, it's good, it's bad. But why is it good? Why is it bad? It's not stated there. It's like, if you ask your kid, you punish your kid for doing something wrong, but you don't tell your kid why you punish the kid. Or you reward the kid for doing something right, but you don't tell the kid why you reward the kid. The kid is not going to learn very fast. It's going to like, okay, I did this action, maybe I do something similar, I get rewarded. But you might be missing the point. So RL in terms of scalar scores like this, it works for AlphaZero because they train it over years of compute. No, it's not going to work for general real life use cases. It's too much variance. Like Go is a very constrained board game. You try doing it in real life, that method won't scale. Right. So I don't think RL is a good solution. So, if ever we want to do tree search like this, okay, one way is, you can get LM to evaluate the score. So this one doesn't have RL involved. This one is just, getting LM to, maybe to classify like into categories. Okay, like 0 is not promising, 1 is slightly promising, and 2 is very promising. Yeah, so you can take my word for it. Like if you ask LMs to give a confidence score, it's not as good as asking the LM to classify like this, because at least when you ask it to classify, it's able to, use semantic meaning of this to classify. You ask it to generate a score between 0 to 1, there's no semantic meaning in your score at all. Right? It just, even for the same like essay, you ask it to grade 0 to 1, you try 5, 6 times, you get different scores. Right? But if you ask it to categorize, you will get likely the same category all the time. Right? So this is a trick if you want to use this, and you could use this to classify your branches, and then use a Monte Carlo tree search like approach to expand out the tree. One famous paper for this is called the MCTSR, Monte Carlo tree search plus refine. So at each step after generating a new like node, they also refine it, right, with a prompt. And the other one is tree of thoughts, which like if you do the depth first search, they will generate a few samples here, and then they'll just pick the most promising K samples to move on to the next step. That's for the depth search part of tree of thoughts. So, I mean, there are various ways to do this. The key idea is you generate a lot at each step, and then you filter them. So you generate sample, filter, sample, filter. You know how you do it? You know, you might do it based on like some kind of you know, Monte Carlo tree search approach. You might do it as a blanket, all the possible nodes you just filter, you know. But you will need some ranking function, you need some scoring function. And this scoring function is not easy to compute. So if OpenAI did this method for the training, you know, I can understand this. You know, they might use this score here from human feedback to, you know, scale it across domains to choose more promising branches for at least, you know, for generating maybe the data set. So, you know, they might be using MCTS style to generate data set. Okay, in order to get the reasoning traces, maybe you do this to find the most promising approach to get the right reasoning trace. I mean, there's a reason why it was called Q star before that. Like the famous OpenAI Q star, no one knows what it is. It's very likely the strawberry model also. So which is O1. So it might be using Monte Carlo tree search style to generate this data set. But at least when it comes to inference time, I highly doubt it's using any form of MCTS because it will take quite long. For those of you who have done MCTS, Monte Carlo tree search, you will know that this is not a very efficient method for real-time production use cases. It's very likely that in production, maybe this is what they use, like agent level sampling. Yeah. So yeah. Okay, I pause here for a while. Any questions so far for this? Like I covered quite a lot of technical content so far. So yeah, good to pause for a while. Okay, if nothing else, I'll continue. So there's a challenge with multiple sampling in order to get the answer is that, you know, how do you make sure that your samples are diverse enough? Like you don't want to have similar kind of output because, you know, that kind of defeats the point of sampling. Like you want to get different inputs from different pathways or different agents. So one paper that was quite interesting is called the prompt breeder by DeepMind. So here they tried to find the best, you know, prompt for the system, okay, by, you know, mutating the prompts. And how do they do the mutation? They actually added, okay, like some thinking styles here, you know, they added some mutation prompts here to like say like, okay, what kind of style do I want to modify this prompt in? So for example, the instruction here could be like solve this math problem. All right. And, you know, it can come out with other styles like, oh, make up a systematic answer that makes you look quite clever and so on. So this is the kind of things that, you know, okay, so sorry, this is a bit different. So like, okay, the main point I want to say is that, you know, like you want to, for example, mutate this, solve this math word problem, you can change it to something else like this. Like after you do this mutation prompt, you could get something like this, like make up a systematic answer that makes you look quite clever. That's the mutated prompt after you get this original prompt, and then you give some like thinking styles and, you know, the mutation style, you know. Something like this could be used to, you know, make sure that the outputs at least are quite different. So like maybe at one branch, you could say like, think concisely. This is branch one. And the other branch, you can say think step by step. Yeah. So in this case, you're encouraging one branch to, you know, give a very simple answer, the other branch to do a bit more complicated stuff. And, you know, this helps to benefit in total because like, if you view this as a multi-agent system, you know, each agent could have different personalities. Like some are concise, some are verbose, some, you know, maybe are more grounded in math because they have a calculator and so on. Some are more like physics-based and yeah, some are text-based. Yeah, so these are different things you can do for multi-agent system. I don't think O1 is there yet, but I think, you know, if you want to have more robust outputs, you need some form of this kind of multi-agent system to have different kind of traits for each agent so that you can, you know, bias the generation differently. So you can think of this mutation prompt thinking styles as a way to bias the prompt. And I think these are quite needed because if you ask the same agent to generate the output again multiple times, you know, you might get the same output. Yeah, I mean, it depends on how complex your problem is. The more complex it is, the the less chance of a similar output. But in general, it's a good idea to bias the generation like this, and this might be done in the OpenAI training when they want to bias the different branches as they explore the research. So this might be done. Again, we have no idea how they did it because they did not release any details. But if we just do something like this here, just generate from the same model, you may not get very different variants between variant 1 and variant 2. So it might be better to have some form of hint, like hint 1 and hint 2 to kind of bias the generation. Okay, so anyway, that's some of my thoughts. All right, so in the web version of GPT-o1, it's very likely that they are using 2 repeated samples because I tried a few tasks, and then you can see that there's 2 of this, and then like the Lily's one is also 2. Okay, I just want to ask, like, do y'all have a similar kind of experience when you use o1? Like, because everyone only has like 30 messages per week, so I only could try this much. How about y'all? What's your experience like? Do y'all see repeated subtasks or steps in the chain of thought as well? Anyone? Yeah, I'm quite curious. Yeah. Okay. One response in the chat. Jerry said not yet. Okay, I guess y'all may not have tried it yet. No worries, no worries. Yeah. If you try it, let me know, okay? Because I'm quite interested to see whether this is the correct observation. All right. This is again my own speculation. All right. So the next up is, OpenAI is claiming that this chain of thought, you could do like more robust checking of the output, but exactly how much can you check? Okay, how much can an LLM check itself? All right, can LLMs be their own verifier or critic? And the conclusion that I come up with like before o1 is that probably not, because like if the LLM is not an expert, like no math, like if it can't calculate numbers properly, how can it critique itself, right? Counting letters, again, like this is not the natural domain of an LLM processing space. So like my intuition has not changed after o1 has come up. Like I feel like you still need to have something more rule-based, more reliable. Like if you use a Python code to generate the 1000 prime, that's better than using LLMs to reason through to get the 1000 prime number. Okay, same thing for calculator. Like using a calculator to multiply 2 large numbers is better than using the LLM to reason through the steps and get your answer. Okay, so there's some merit of training the large language model on its own rationale, like the star approach. There's some merit to that, but that is not the best approach to solve stuff, because some things you need reliability, and these are all reliable stuff. Okay, and LM not very reliable. So you need to marry the two of them together. o1, I believe, did not use these tools to make it more reliable. It's probably just using LM itself, and that's a huge drawback in my opinion. All right. Okay, Lucas, you said sometimes it uses a lot of thinking steps when the problem is complex. Yeah, around 15. Yeah, of course, of course. The more complex the problem, the more the chain of thought might need to generate. Like it could be in the training set as well. Like the more complex problems have greater number of training sets, have greater number of steps. Okay, let's move on to the next point. So LLM Modulo, I covered this last week. The main idea is that you have a like over here they have a plan. Okay, the LLM responds a plan to solve a task. Okay, so the task is given by the user. Okay, have a plan here, and this plan is then critiqued by many critics. So these critics could be rule-based critics or LLM-based critics, and then you can refine the plan based on this, based on critic feedback. So actually the whole diagram is very, very complicated. The main point I want you all to look at is just the point here. Let me just draw this. Okay, this is by Prof. Subarao, and the main thing I like about this is that the idea of a rule-based critics that could give you like whether or not the plan is correct. Okay, I actually may not agree that you critiquing a plan is the best approach. Okay, I think maybe you can just treat this as LLM response instead of a plan. Okay, so if we just view it in a more generic sense that, okay, you are giving an LLM response, and then maybe you have different critics here, like your critics could be, for math, it could be a calculator, for programming, it could be a compiler, this critics could, evaluate some stuff for you and tell you, hey, your code is wrong, or hey, your multiplication is wrong. So this makes a feedback loop that makes the LM output more robust, because this critics here could be very well grounded in the ground truth. Yeah, I mean, even if it's an LM based critic, to see if like sentiment is positive, I think it's fine if the critic that you use the LM for is something related to LM strong point, like text understanding. Then I think that's fine as a critic. Okay, so stuff like this makes the system very robust. Based on my experiments with O1, I'm not very sure. In fact, I'm quite sure that it doesn't use this kind of features at all. It probably doesn't have a calculator, code generator, and so on. So if you integrate this inside the reasoning steps, as one of the steps, to check with the compiler or check with the calculator, that is going to make it much better, in my opinion. So I think this is a sentiment shared by Prof. Subara also. He also had a LinkedIn post talking about this. I think this is something missing right now, and yeah, this should be added in the subsequent versions of GPT-o1. Okay, now we go to my thoughts. Then after that, we have a short discussion. So I think O1 is pretty impressive. Okay, although I've been saying that, hey, O1 doesn't have this, doesn't have that. I know this is supposed to be like the first model of reasoning, right? So that's why they call it O1 instead of GPT-5, right? Because they don't want to compare with GPT-4. So O1 here is actually quite impressive. It answers a lot of logical questions, a lot of code-related questions. Given the fact that it doesn't have a compiler, or rather, given the speculation that it doesn't have a code compiler, it's actually not too bad. Like, if you can do code stuff, all right. You can do a lot of things that 4.0 cannot do. Okay, and again, this speculated lack of tool integration means that stuff like the verifiers that are rule-based or this can't really be used to enhance the LM performance. Okay, but this can be fixed in a later version when they allow for more agentic forms of tool use, or you could wrap O1 in an agentic structure that allows for tool use. So that's possible. Next, I feel like O1 is a bit like an agent because like you have multiple steps and then you think through the steps, and like I don't think that this thinking process here, like maybe what they should do is they should have a like maybe the thinking process should be should be more like concise, because like right now it takes like 40 seconds, 1 minute for some very complex problems, and like and you're not even able to steer this thinking process much. It's all done like based on the fine-tuning data sets and so on. Like while I like the idea of having the LM be able to think through their response more, I actually think that this part of the rethinking and so on, it might be better off left as an agentic framework over it, because if you were to use the star reasoner to like give you your rationale, and then you fine tune on your rationale like this, the thing is you can't change the way the fine-tuned model thinks. It's very difficult because it's already fine-tuned in that manner, right? So I think there's benefits to such an LM structure. I just don't think that this LM structure should be the default that you use, because if it's going to be the default, you think about it, how are you going to steer its behavior? You can't do anything to it. This is already given to you, all right? And even if OpenAI wants to give us a parameter to control the number of steps, it's also quite difficult because you are only influencing the inference time. Okay, but all these steps are actually all trained in the pre-training phase. All right. So, but if you put it as an agentic structure, you can get more compositionality, more customizability. You can say how many steps you want. You can tell the model to think in a certain way and so on. And yeah, one other thing about this rationale stuff thing is that if we just package this all the rationale learnings in O1, then what happens is that we can't really say how much of the model improvement is due to the base LM being stronger versus how many improvements is part of the chain of thought. Yeah, so this makes it very difficult to compare with other models, because obviously the inference time is much longer for this and it costs a lot more. Yeah, so I prefer if they could just take maybe the Like, I mean, they could train on rationale and so on, but you don't have to have the O1 take 40 seconds to come at the answer. It could be the same time as before. Just fine-tune on the rationale-based data sets. Yeah, so you say it's chain of thought baked into the model. That's correct. And I think that's also the reason why, I think like this kind of LLM model with the chain of thought baked into it can be over biased. Like I will much prefer if the model is already like, like just 4.0, the earlier models where you could just already get the answer out fast. And the chain of thought we can we can do fine-tuning on our own. Like rather than have OpenAI fine-tune for us this, because this is really use case dependent. So unless OpenAI claims that they can do the chain of thought for all different domains equally well, then sure, they can fine-tune for us. Okay. By the way, these are my thoughts. I really think it looks more like an agentic framework already, like rather than there's a base LM itself with this kind of training method. Okay. Yeah, but again, these are my thoughts. Like you might think that, oh, this is wonderful, I can just use this without the agentic framework. Sure. But I do think the agentic framework is still needed because you can have more customizability that way, and you are able to integrate stuff. Okay, again, there's a caveat. You can still use, sorry, let's go back. You can still use an agentic framework over GPT-o1 with even if the chain of thought baked in the model. It's just going to be very slow. That's all. And the agentic framework might correct some stuff that chain of thought baked in the model cannot correct. So I think this is possible. It's just right now this is slow and expensive, maybe in a few years this will be viable. Okay. But
Can I clarify something here?
yes.
I think the inference time cost for O1 depends on the specific task, right? For example, if ask how many letters in strawberry, it just takes a few seconds. It's not that costly. So I was wondering, I think it's possible that combining agentic framework with O1 doesn't drastically increase the inference time cost, because if the agentic framework decided that the answer given by some O1 agent is good enough, then you don't need to like do so many round of ensemble or voting as whatever, right?
It's possible. It's possible to offload some processes of what agentic frameworks are doing now, like the reflection step and so on, into the LM itself. Okay, it's just that.
So it's just whether you want to front load the time used to individual more powerful agent, or you want to backload it into your agentic framework. That's how I look at it.
Yes, it's possible. It's just that, if you use the LM to front load the chain of thought, you can't control it much because it's already pre-baked inside the training. So
I think in principle, there's nothing prevent you from still giving the model some system message, right? So long as it doesn't directly conflict with what is the default behavior is, you can still like do some minor steering of the chain of thought. But the problem is currently they don't allow you to give the system prompt, so we can't test it for sure. So need to see. I think in principle, nothing like there shouldn't be anything prevent you from just giving it some system message. Yeah.
Yeah, I mean, we can try it out when the API becomes more common. Like right now, the API is only released to certain tiers of.
Oh, no, I'm saying like even you have the tier 5, you cannot do it now. I don't know why. Yeah, I don't know why they don't allow.
Yeah.
Maybe they cause some erratic behavior. Yeah.
Right. So again, this is about bias. You see, like we could bias a lot of things in the LM. It will help to improve the performance on certain tasks. But if you want to do it on other tasks, you might not want this bias. And if we have an LM that is already biased like this, then the LM may not be the best LM to use for an agentic framework. So
okay, but my question is, for those benchmark, those domain that O1 does not have significant improvement on, does any form of chain of thought prompting help? That's my question.
I'm not sure because like English literature,
Yeah, exactly. Yeah, exactly. Yeah. So maybe like even if you prompt it by yourself, you also cannot improve too much. Maybe. Because those are not like reasoning based tasks. As in the reasoning doesn't really help too much. Maybe. I don't know. Yeah.
Yeah, to get some English lit experts and like public relations to comment on this because these are not my domains. All right. Yeah. But that's a very interesting discussion, Zeri. I think indeed, if the chain of thought, is beneficial for all domains, it might make sense to put it in the LM. Then we can do less for the agentic framework. That's possible. Okay, let's move on. This is an opinion question, by the way, so there's no real right or wrong answer. It's just I prefer that LM is faster. That's all I'm saying. Yeah. Okay, so next, reinforcement learning to train. Like if you've seen the tree search diagram, I think using reinforcement learning to train the tree search, it's not that great because like how do you know how a result is correct with just a number, all right? And how's the reward model going to learn effectively across tasks? So my answer is that I don't think it can. So the better way is to just ask LM to classify the response, okay, incur some error here, and then like you might correct this later on with expert data curation. So there are some ways to do this, or you bootstrap with expert data first, okay, before you ask the classification and so on. So this way of doing some form of data classification, like it might actually scale better than using the reward model. So this I'm not too sure because of course if we ask it to do classification, it might also have a narrow kind of focus because you only have this much data. So the reward model can potentially scale to a lot more things. It's just a scalar number, assuming they're using a scalar number to gauge closeness to the goal. I'm not too sure whether this scalar number is better or asking the LM to give the response is better. My opinion is that this is better because because this contains more info than just scalar number. Again, caveat here, I'm assuming the RL they're using is a scalar number to just gauge how close the response is to the goal. All right. So if they're not doing something like this, but they are doing something like STAR, a self-taught reasoner, where you bootstrap reasoning to LM dataset. If they call this as RL, this I can accept because I think this bootstrapping of reasoning but makes sense to me. It's just that it builds a lot of bias, you see. Like you can't unlearn those bias if you fine tune that. But I think that's fine to me. So if the RL that they are using is this, I think it's okay. But if the RL they are using is this single number to scale across tasks, then I think this is not very good. Okay, so these are just my thoughts. Again, I'm happy to discuss more if you want to. Okay, so
Yeah,
there you go ahead.
I okay, my speculation is they do not just use, of course, like they do not just use RL for the chain of thought post training. They definitely have fine-tuned on both expert and synthetic chain of thought reason data because RL alone, there's no way you just use RL, you can steer the model to just behave in the reasoning pattern you want. Exactly because of the reason you said. Like it just reworks, signal is just too sparse. But it's useful when your base model already have a sense of roughly what kind of output it want through fine-tuning, simplified fine-tuning. Then after that, you use RLs to just do another layer of very, very granular fine-tuning. Yeah, so for that scale reward signal might still be informative enough.
So you're saying bootstrap already. I mean,
Yes.
you already
I mean,
have.
SMT is for the bootstrap part. Yeah.
Okay, then that I think can still be feasible. Like the first part that I'm talking about here, classify the response. This might be already supervised fine tuning. Like you might already ask the experts to help to classify and so on.
Yeah, you can use this. You can think of like multi-stage alignment. Like you can use different method at different stage of the pipeline. Right?
Yeah, it's possible. I mean, I actually strongly believe that the last stage, because OpenAI is quite big with RLHF, the last stage might be something similar to RLHF. So this reward model might actually really be used. And if we are talking about this as the final stage with already the big baseline knowledge baked in, I mean, this might be possible. This might be possible. Okay, yep. So I think we leave it as that because, obviously there are some ways that say that, okay, fine-tuning is enough. Some people say reinforcement learning is needed. I'm of the camp that actually fine-tuning is enough, but OpenAI might be of the camp that reinforcement learning is better. So I guess RL does have some benefits if you have enough scale. So OpenAI certainly has the scale, so maybe it's useful for them. Right. So next we have this. I think instead of just using one chain of thought baked into the model, you could have multiple agents with different biases, can create diversified thinking processes. Okay, so this actually, if O1 is fast enough, this might be done with agentic framework over O1. That's possible also. So this is something that I think works better than just, pre-baking the chain of thought inside the model. Okay, this is my speculation, because right now it doesn't have any tools. If you need to do some simulation to, see the response, like maybe you want it to evaluate a move in a new version of tic-tac-toe or evaluate a move in a new version of chess, it might fail. Like existing versions of chess, tic-tac-toe, maybe it will still work because you might encounter that before in the training set. But if it's something quite different, it might not be able to solve it. Okay, so this is something that I'd emphasize is that if you want to do some form of search, okay, in an environment, okay, you might still need the environment, or you will very likely still need the environment to test it out. Okay, you can't just test it with just the LM itself. Okay, so this is one thing that I like to highlight, especially like for robotic simulation and so on. I don't think O1 is going to work for those right now. Okay, you might need to still bake in the simulators inside. Okay, not bake in simulators, sorry. You need to integrate the simulators as part of the process. And this is a very important last point. Maybe I should put this as the first point. There's a missing part of memory structures. Like, you want to learn from the environment, you might store what you learn in a vector, in a vector DB, or in a knowledge graph. And you can extract what you need, like in terms of RAG or like knowledge graph, you can take out the relevant triplets. I think this part actually helps you to learn from experience, and you can extract out the relevant experience that you need based on the task at hand. And right now, O1 doesn't really store this. So like when it's doing the chain of thought, it's just using all the text above to interpret. That is not the most effective way of doing things. So if we already have this kind of memory structures for the environment, like one could be a vector DB, one knowledge graph, another memory structure might just be, you do in various forms of abstraction space, like maybe graph rack, you give compressed versions, summarized version of the text and actual text itself. Something like this could help to improve the model's ability to reason and understand the world. So this is something missing. I'm quite sure they'll add it in the future. I'm actually actively working on this for TaskGen also, because I believe memory is the one of the most important things for learning. So this, in my opinion, is something that is very, very big and something that is missing in O1 right now. Okay, questions. So I'm just going to go through the questions, and then I'll just pause for a while. If you have anything, you can add on to each question. So the first question is chain of thought the best way to elicit reasoning? And my answer for this is, yes, for some contexts, like for example, for word problems and so on. Like yes, you can do that. Okay, but no, if you need like external verifiers, simulators, I mean that could be part of chain of thought also, but not the current form of chain of thought. Like you need to bake in all this inside the model itself, and also like if you need to have a way of retrieving info from some knowledge bank. Yeah, just the chain of thought like that wouldn't cut it, because the knowledge bank might not be the LLM's memory. It might be an external memory. Okay, any other comments for this first question? Okay, then I'll move on to the next. So what are the potential downsides of reasoning purely by next token prediction? Okay, this one I think I covered. In case it may not be reliable because the LM might hallucinate things. And in fact, if you look at the technical paper, O1 actually may hallucinate more than GPT-4o. And that's because, like, if you ask it to reason too much, okay, this is the same question, the same as the next one. Ask it to reason too much, it might overthink things. And the earlier reasoning steps might be taken as ground truth. Because if your context is that long, all the earlier parts there, they might not be able to differentiate what is actually given in the problem itself versus what is thought of by them. So there's this case, if you think about things too much, even for humans, sometimes what you think in your mind might get consolidated as what is really happening. So that's something dangerous because, like, for example, expert witnesses, the more they revisit the scene in their mind, the more they adjust the memory. So over here, we don't have the adjustment of memory for O1 because O1 weights are kind of fixed for inference time, but the additional context, additional irrelevant context will hurt performance. So it's only good if you are sure that, whatever that the model outputs is relevant. Like if it outputs something wrong, like the reasoning step goes haywire to another side, and you use that as context for your later reasoning steps, that's going to bias it in a different way than what might be correct. So there's definitely drawbacks of this, especially, if the big chain of thought in the model itself is not suitable for your problem. Like maybe you're doing a problem on, I don't know, some English problem that doesn't require chain of thought like how they do in math, then this might hurt the performance. Yeah. So next, how could the data set be created for O1? So, the rationale could be generated by LLM, put into data set to fine tune, and then repeat. And like this is the star method. And then PhD students could help to give ground truth for first iteration. So I think this is probably the reason why it fares so much better at exams, and like it's probably a handcrafted data set that's not available online or anywhere else that other LM providers have access to. So again, LMs, if you are talking about the base performance, is only as good as your data. So they probably spend a lot of effort making good data here. Okay. Then the last question is, have you already reached the limit of what LMs can do for problem solving? Actually, I'd like to say yes. because O1 is a huge departure from earlier models. Yeah. So the fact that they want to bake in the chain of thought into the model itself, this might be, an indication that just training it on the web data, like web data might already be mined fully. Yeah. So I mean the next frontier is yes, we can say that we can use better agentic systems to elicit understanding, but I don't think this will scale anymore because like there's only so much data you can mine, and a lot of data you mine now is going to be synthetic data generated by other LMs, which may not be the best kind of data to use. Yeah, I mean, one way I think they mitigated this is to use PhD level student knowledge to augment data, but this is slow, potentially inaccurate. So I don't think this is a very scalable way to imbue knowledge. I think what we need to do now is we need to look at more neurosymbolic approaches. Like then we can consider like learning structures, like for example, knowledge graph. Okay, maybe not the default knowledge graph, but maybe new form of knowledge graph that can contain more abstract kind of concepts. All right. So we need to learn these kind of things and learn how to extract them for answering multi-agent systems and so on. So there's a lot of ways to do this reasoning and stuff like this. We probably need a lot more things on simulators. Oh, I should put simulator here also. Simulators. Like we need a lot more kind of integrations with external structures like this, memory structures, multi-agent systems, simulators, and so on. Just purely relying on LMs alone to solve problems is likely not going to be the best approach because LMs are not a very good verifier or critic. I mean, O1 can do decent for word problems, for logic problems, maybe because it's very similar to the training data set. And humans we don't think too far out from the training data set actually. Like you might think you are thinking of something new, but that could be a training data set also, because we are all influenced by the same environment. It's hard to think of something new on your own like that. Yeah. So yeah, that's more or less my thoughts for this. I'd like to invite your maybe last 5 minutes. Just chip into any of these questions, or like just ask your own questions also. Yeah. So go ahead.
So to add to the last question, because it's what I'm thinking about right now, is there a possible advantage, and I already know we're talking about LLMs and their limits, to adding this neurosymbolic framework and these different modules and systems that the LLM will already have to interact with, probably anyway? Is there an advantage to creating this framework and then having the LLM train with the framework at train time, essentially? So as it's curating the data set and it's pre-training on it, also utilizing these other, well, I guess it wouldn't be a pre-training, it'd probably be more fine-tuning.
You're talking whether we can fine tune with the memory data set? My answer would be no, because your memory will change. Like you can fine tune to like a fixed environment, but if your environment is going to be dynamic, you can't fine tune on fixed memory. Like the memory is going to change with the environment interactions, and it's better to leave it outside of the fine tuning.
Okay, so you don't really see an advantage to integrating it into the train time.
Unless the environment is the same, then yes, then there'll be an advantage to integrate in train time. If not, there will be this issue of bias, you see. Like if you bias your model to a certain form of memory, and at test time you give a different form of memory, it's hard for it to generalize unless it has seen that memory before. So I actually think that the best way to generalize is that you'll be input agnostic. So you don't give it like the exact memory form that you're using. Maybe you give it a description of the memory itself. Like then whatever form of memory you want to use or whatever form of input, you can map to a common space. Yeah. Either that, or you just have to train over a huge data set that contains all possible kind of configurations. Then that might be possible. Yeah. There I did that make sense?
No, you're good. You're good.
Yeah. I think you're thinking about stuff also. Like I actually do think a lot of improvements can already be gained by having some form of knowledge graph with state transitions. Like we were talking about state graphs, right, in the last few sessions. And I think something like this is quite important to put inside a reasoning module actually. Like you cannot just reasoning over thin air. You need to have some grounding with the environment.
One comment on your last point where you said there's not much data left to make use of, right? I feel like it's still the signal problem, because a lot of data on the internet that, like, even if you train an LLM on research paper, right? I think I saw from somewhere, I think it's a very good take on this, because the thing that's valuable is not the, like, in terms of the academic research, the thing that's valuable is not the paper itself. I think it's Terence Tao made this comment, if I'm not wrong.
Terence Tao, is it?
Terence Tao, yeah. It's the thing that the whole thought process that leads to the publication of this paper. That's the thing valuable, but that's not explicit. You cannot find it anywhere on internet. That's from the, yeah, that's inside those researchers' mind, right? You can't really train on those things because it's not available. Yeah. So I guess that's also why I agree with your speculation that they recruit a lot of PhD students, because that's what's valuable, right?
Yeah.
So I guess the next step is probably to change the mode of how you extract valuable data. Yeah.
Yeah.
Because
Thanks,
it's not there, it's not readily available on internet. So we have to think of another way to how do we extract. There's definitely more valuable data, yeah, but it's hard to get access to those.
Or you can create your own problem creators. Like you create from first principles the problems, and then you just mix and match the steps. Like for math, you could just say, okay, I want to do my addition, I want to do a modulo, I want to
Yeah, but that's not what leads to the a very good research. Like those things that everyone knows. But the good thing is the insights and the intuition of very high quality research or those researchers.
Mm.
That's not common. That's not just facts. That's like with the accumulation of so many years of experience or whatever. Like yeah, that's something very valuable. It's not. I would argue that's not even common sense. Yeah.
Yeah, I wonder how humans learn that though. Like, how do the knowledge get baked into PhD students' head if they are using that for training the model? So I think understanding more about how we learn stuff, which I believe a lot to do with memory, will be needed to model this in the AI system if you want to learn without humans.
Another thing is really currently their approach remind me of AlphaGo and AlphaGo Zero. So I'm wondering, is it possible that for us to totally get rid of the bootstrapping part?
But you know AlphaGo Zero or
Yeah.
Alpha Zero?
Zero, yes.
They also make some mistakes that are like, because they don't bootstrap with humans, right? It's possible to,
I know
find
you can find adversarial move to beat
Yeah,
it.
correct.
That's not the point, right? The point is for grandmaster level they can beat grandmaster level chess player. For me, I'm okay with having a system cannot calculate 1+1, but it can help me do super hard tasks. So those are still valuable things. Yeah, but I'm just wondering, can we transfer the same intuition and how we do things from chess play to language?
There's another difficult. I mean, I take your point that your system doesn't need to be perfect to be useful. Like it can be already good enough to be useful, like ChatGPT. But there's the practical issue of training AlphaGo, AlphaZero on real world systems is that it's typically a two-player game for AlphaGo and AlphaZero with a clear winner. So in a real world context, unless you can model it, two players of almost equal strength, clear winner for the task. If not, it's very hard to train in this adversarial way.
One is in that well-defined environment, you can have a clear reward signal which one's better, right? But I think you can do the same thing for a lot of tasks as well, like the math, the technical domain. A lot of tasks is there's a clear cut which kind of quality result it has higher quality. So you can for that kind of task, you actually I think it's possible to have a very clear defined reward signal. Yeah, it's just the reasoning trace that's more important. Like currently they just imitate human. Yeah, is it possible to do it in a self-play manner?
Actually, idea made me think of this. If you could have two models creating two rationales like that, maybe you can have a human critic or like LM critic who choose best rationale. And then you can use the best rationale for fine-tuning. So this is not in the star paper, but you could have an adversarial kind of environment like this also where you can like slowly get better and better rationales. Yeah, I'm not too sure whether this is how we learn though, because this feels a bit more of like a hack. I don't really think I critic in my head like the best rationale I learned from it. Yeah, but based on what you're talking about, does this make sense to you? Like this is what I like.
But if you use a human critic, you are still trying to distill the human knowledge, right? So
Okay, then we don't use the human critic.
for the judge, in my case, it's just a clear defined problem. For example, if it's a mathematical problem, if you have the ground truth of the answer, then that's what gives you the reward signal.
Makes sense. Yeah, that's interesting food for thought. Like, can we really learn without any humans? Yeah, I actually think the answer right now is no, because we don't have the right structure to learn yet. We can learn generic chain of thoughts kind of things from online data, but the online data doesn't really specify out these thoughts very clearly. So this is something that I think this will need some work. But the thing is, the question to ask then is, are these reasoning traces really useful for everything? Like, or is it only for some problems?
Yeah, that's the question I asked just now.
Yeah. So I think it's only useful for some problems actually. Some problems you don't really need these reasoning traces. Okay, if not, any other last comments before I end the session today? Okay, if not, thanks so much for coming. I think this was a good chat. Clearly, there's still a lot more to do to get human level intelligence in LLMs. GPT-o1 is definitely not PhD level intelligence. I mean, it's limited PhD level intelligence, but a lot more needs to be done. And my bet is that we need more stuff on memory structures. Okay, and Zeri's bet is that we need more things to bootstrap without humans. All right, so let's see what we can do for this. And I'll see you all again next time. Okay, bye everyone.